Okay, you're on.
I'm on, and so are you guys. And hello, everybody. Welcome into our big vlog podcast once a week. We are the board officers and members of the Santa Barbara Astronomical Unit, the big telescope and astrophysics club. And this is the SBAU Astro Hour. It's number 211 as we plunge into our fifth year on the big Zoom screen. Proudly, I am your host, Ronnie Heron, one of the board members, wearing my green Tamo Shatter, which doubles as a French beret green later in the month. Welcome to St. Patrick's Day week. Our club is supported by Santa Barbara's beautiful and popular Museum of Natural History, where we meet at least twice a month. Our first Friday general meetings and our second Saturday night star parties. We also do outreach, tons of it. Telescope viewings of the night sky out at schools and campgrounds, hotels, and you are invited to come join us if you really like the fun science of astronomy. Check us out on sbau.org. What are we going to look at this week in our program? We take a long, hard look at our waning moon, plus a deep look inside it. Yep, there are levels and layers out there. Liquid iron shell, 90 kilometers thick, even a magnetic field. We're going to be catching an asteroid in action. It's 29 amphotyte. Sounds like something you could dig up. And the vernal equinox is almost here. Incidentally, our regular weekly planetary roundup includes some crescents, one on its way to inferior conjunction. That's a terrible thing to say about a planet. Mars just went through its gibbous phase. Neptune and Saturn hidden in the sun's background. And incidentally, I saw this in the New York Times, a headline last Wednesday. Astronomers knew Saturn had at least 146 moons. They just spotted another 128. We may be talking about that.
So we're at 200 now?
274.
Wow.
How did they do that without what was the long-time orbiter named after the Cassini?
Cassini.
I've got to get my Italian out of going again. Let me introduce the people you're seeing on screen, plus one cat. Jerry Wilson, our beloved president, is with us. Jerry?
Good morning.
He's married to Pat Forgy and has been in office for 6-7 years, following the reign of Tom Totten, who used to be on our screen. Chuck McPartland, in his Irish green, our outreach coordinator, the best in America, in charge of most events, including picking up lost needles on the floor. Never mind. Pat McPartland is his wife. Between them, they hold down 3 different offices, 3 different duties for our club: merchandise and treasurer and outreach. And doggone if Tom Whittemore didn't join us. He's married to Maureen. Hello, Tom.
Morning.
Former Westmont College professor, beloved out there, and edits our newsletter. Tim Crawford. He's got a new look.
Sorry about the photo. I got a new laptop, so I'll duck out of the way if I can.
No, that's okay. We'll get used to your ugly mud, Tim.
That's our lunar eclipse from the other night, Ronnie.
Really? You were out there did you do this at the shopping center or your home?
Yes, I did.
Went out there
an iPhone.
I simply remember not going, even though I don't have a scope, because it was cloudy downtown, or at least I thought they're not going to meet out there, of all places, in a shopping center.
No, there were like 6 people with telescopes and 47 customers.
Who carries the cardboard boxes that we put around the street lights?
Those are in my garage, but Charles Schuler came and put some garbage bags on the lights.
Yeah, Charles Schuler's about 6'9" or something, and he just reaches up and puts bags.
So he just bent over to put them on. Huh?
Yeah.
Well, now everything had shut down by lunar eclipse time, except for the movies. I imagine you were right outside, right?
Yeah.
Okay, and how's your wife, Karen, Tim?
Everything's going pretty good, except it was a little bit dicey there when I got this laptop.
You got a laptop like I did.
Yeah, I just looked all over the place. That Apple stuff is expensive. It's expensive.
So you're on a Mac.
Yep.
Well, welcome aboard, gentlemen. We got silly stuff to talk about, and he set out a whole bevy of science cartoons, silliness, thought provokers. Let's call those up. through our beloved president. This one I didn't really understand, but let's see what we can make of it. Is
It's
this
not
about
that funny,
half-lives?
but it's that there's the annual interdepartmental water balloon fight. And the people from the Meson particle physics group down here and the planetary scientists up here are equally far out of what's going on now in the flying water balloons. So the point is they're equally matched.
This
Because they're
represents a
equally
real
far out
contest.
of their area of expertise.
These people get together and really throw water balloons, Jerry?
No,
No, just in the stick figure land, just in
Oh, just on
KXCD or something.
I thought maybe this had something to do with half-lives of
No,
half-life
no,
of
nothing
radiation.
so elegant.
It's just a graph of size versus time.
Okay, got it.
See,
Well,
10 to the
that's
minus
interesting.
30 kilograms, and here 10 to the 30 kilograms.
Are mesons also called pi mesons?
That's one kind of meson.
Oh, I see. PI. Doesn't have anything to do with circles.
Okay.
So anyway, that's a good one. All right, heaviest objects in the universe. I don't recall getting this one. You're going to have to, the sun is heavy, the neutron star is heavier, black holes are really heavy. My love for astronomy is the deepest of all. Yep.
Okay.
And the country's going could be a sixth one on that screen. Here we go. Two views of Mars, one from space and one down below. After exploring the monotonously stony landscape of Mars, it probably needed a journey of inner discovery. That means we're going inside looking for the frozen water.
No, he's climbed up a mountain and he's in the lotus position meditating.
Oh, I see. Okay. Okay. And we
So
even
that
had a
must be AI.
Yeah, we even had a helicopter on Mars. Okay, this is another interesting one. Which one is this one? The sound? Oh, this is a Tom Whittemore pun. The sound from a musician on stage, ladies and gentlemen, bounces off the auditorium walls to surround the audience. Okay, brace yourself. The sound from a pigeon on stage does not do this. The reason is acoustics. Acoustics.
No explanation.
Okay. Are we scraping the bottom of the old bar? What is this one?
Now this is not necessarily a comedy thing, but I mean the explanations are the funny part. Let's see if I can get.
All right, here we
So
go.
definition: a traditional planet when Pluto was a planet. So then we had 9 of them. Modern.
Okay.
When Pluto is not a planet, we have 8 of them. When dwarf planets are planets, we had 17 plus.
Okay.
When ultra traditionalists, only the classical planets are planets. So that's 5. That was naked eye stuff. Condescending planets, only giant planets are planets. The rest are big asteroids.
Wow, things are changing rapidly.
Simplistic, anything gravitationally round is a planet.
Okay.
The sun is a planet. There are 37.
There you go.
Grounded, the grounded definition, only objects a spaceship has landed on are planets.
Huh, 10 items.
Regolith, anything covered with dirt and ice and stuff is a planet.
Infinite.
Lunar, you can't be a planet if you don't have a moon.
Oh, all right. Solipsistic?
Solipsistic,
Right.
Earth is a planet.
The only one.
That's just one of them, us. Judgmental, only the prettiest ones are planets.
Okay.
They're making fun of how we define planets, if you haven't caught on to that. The
Is flat
empiricist, only worlds that I, author of this table, have personally seen are planets. Marine biology, only objects with oceans are planets.
Okay, that makes sense.
Maritime, only objects with surface oceans are planets.
Wow.
Now there's one out there too.
What's that one?
Titan.
Yeah.
Universalist, they're all planets. Existentialist, what if space itself is a planet? Dude. Spiteful, only Pluto is a planet.
Only
I like that one. I like that one.
Yeah. Okay, here are a couple of scientists going quantum on us. It looks like they're entangled. I've discovered, he said, something new in quantum mechanics, Arthur, but it's neither weird nor totally unbelievable. The other guy says, are you mad, von Schwartz? You'll never get published. It's true. It's got to be
It's
really
got to
far.
be sensational.
Yeah, it's got to be cats in boxes. Here's a father astronaut talking to his kid in the future, and this is what happened to all the space debris and that's orbiting. Yes, it's true, son. When Dad was your age, the Earth didn't have any rings.
And the rings are all space junk.
You know, it made me think maybe most of the junk is at the equator area. How much of it goes over the pole, you suppose?
Fair number.
Okay, but most of it, I'm sure, is above the equator.
No, no.
You
I
don't
mean,
think so?
all of the geosynchronous stuff is kind of close to the equator, but
Well, okay, this is a crescent of Venus.
Venus.
Got it. That's what it looks like, huh? In your scopes?
Now, in the weekly planetary roundup, Mercury is ending its evening apparition. And so if you're trying to find it, good luck. Inferior conjunction is on March 24th. It'll be right lined up with the sun, but it won't be on the sun's disk. It'll be above the sun. It'll be lower than the sun. Venus is a couple of hundred times brighter than Mercury at magnitude -4. It's low in the west, and by March 17th or 18th, that's today or tomorrow, it sets while twilight is still bright. And these are two pictures of Venus at this phase. There's the end of its crescent phase, and here's a phenomena where the atmosphere actually extends the crescent phase around. And this is what it will look like in a daytime photo or visualization or looking at it with your eye on the scope currently.
Huh.
It's called the most unusual Astronomy magazine. No, Sky and Telescope says it's the most unusual phase. It's a hairline crescent, just 1 to 2% illuminated.
Wow.
So on the 22nd of this month, Venus will be passing 8 degrees to the celestial north of the sun. And then it will become a morning object.
Vernal equinox is heading our way, isn't it?
Yep. Thursday.
on the 20th.
That's interesting. It's almost like the wedding ring of a solar eclipse, but how does the sun hit all sides of the edge?
If the planet were going to travel across the disk of the sun in a transit of Venus, which Chuck has a T-shirt commemorating,
Yeah.
then you would see a ring around the planet due to its atmosphere. But
Yeah,
the sun
Ron, see,
What's
Jerry
that?
said that earlier, that you can see it all around like that because the atmosphere is transmitting the light.
Right.
Our atmosphere.
But
Correct.
if
But
it
if it were on
transited,
the face of the sun's glare would
obliterate it?
outshine that. So you would just see a dark circular disk going across the sun. But when it's
Jerry,
off the sun, you'd see the atmosphere all the way around.
Jerry, can I make a comment here, if you don't mind? The eclipse the other night, I got several questions of why the moon is red. It's the same effect, right?
Yeah,
No, very different.
it really
The moon
is
is
because
it's
it's the
being
sunlight
illuminated by
coming through the
everybody
Earth's
else's sun.
atmosphere.
Mhm.
Yeah.
Too
Just-
good.
We need just
Bruce,
one person talking at a time.
Oh, okay.
Bruce, what did you say?
I said the moon, the blood moon, is caused by it being illuminated by everybody else's earthly sunset.
Yeah, I sort of
Yeah,
didn't get
all
that.
around the earth.
Right, I now got that.
Okay.
Okay, so this is inferior junction? No, which one? Conjunction. But that's
Yes.
Really washed out, Jerry.
Okay. See this here.
washed out as it was. What planet is that? The moon or Mars? That's Mars.
Mars.
Yeah. southern ice cap. This one is taken by Christopher Go. The moon is getting, or not the moon, Mars is getting quite challenging to
Yeah.
photograph because it's getting so small. It's about eight arc seconds across right now. It was about 14 when it was in conjunction, and some conjunctions it will, or oppositions, I mean, it will be up to 25 arc seconds, which is half the size of Jupiter. But
Okay.
still,
Means we
But it-
passed it. We passed it on our orbit. We passed its orbit.
yes,
Passed it in the inner lane of the galactic.
we're pulling ahead. We've gone around the racetrack faster than Mars did.
Gotcha, right?
Now, whoops.
Ooh, that was heavy, whatever it was.
Oh,
Can't
it's
wait
just
to
that my program not accepting the order I put the things in.
see it.
No, this, to err is human. To really screw up requires a computer.
It does it
true.
all without me too. Can you
This
see
is all
this? Or is
washed
it-
out too.
This is washed out. Okay.
Yeah.
Let me work on that.
Well, Tim Crawford, you look better with your laptop, I got to tell you.
Well,
We'd see you
that's
looking.
debatable.
we
Okay.
used to- Okay, here's Jupiter.
This is a very nice image of Jupiter, also taken by Christopher Go.
Wow.
Right now, Jupiter is not as big as it could be. It's about 38 arc seconds wide. It can get up to 50, but still, this is a lot bigger than Mars and a lot easier to see surface features on. The
He must
striking
be
thing about this for me is the extremely small size that the Great Red Spot has reached in the last decade.
he must be at quite some elevation to avoid all the turbulence that we get.
He's in the Philippines on the same island that Edgar's from.
Oh,
Okay.
Oh, I didn't
Wow.
know that.
Yeah.
Haven't
Okay.
seen Edgar Ocampo in a long time. And the Great Red Spot just proves that planets have belly buttons.
Yeah.
Now, switching to our moon, which is flirting around with last quarter, is the heading toward last quarter. These are some pictures taken by Robert Cazellac in Paris, not in Paris, but in France. Don't know exactly where his observatory is. So this is what he's trying to get is in this crater here in Ptolemy, or excuse me, Albatignius, right here, which is near Ptolemy. There's this central peak here, and there is a crater right on the top of that central peak. And here's his photograph of that central peak, processed. This is also his photograph. So this is a 1 kilometer wide legend down here. So this is about a kilometer across. And this is a lunar reconnaissance orbiter from NASA, picture of the same thing. It shows the same crater, but in that crater, there is this smaller crater.
No.
And that's what he's trying to get with his picture. So it's easy to see this crater, but he's dancing around and that you might see a feature here that you could think you see it there.
Yeah. Yeah.
And as Stephen James O'Meara once said at a star party when I was where I was at, he said, if you ask someone, do they see it? And if they hesitate before they say no, that means they saw it.
But are we talking about a meteorite crater or a volcanic crater?
No, this is a hit, probably an impact crater.
Really?
There's
Just
no-
happened to hit the center of that mountain. Just makes it look like
Hit the center of the crater in the center of the mountain.
Wow. Amazing. And there's a little one in the middle of that one on the top.
Yeah, right there.
Okay.
And in his, if you squint a little bit, you can kind of see that
Right
there's
there.
a darkening there.
Yep.
Yeah. So he's claiming he got it, and I believe him.
But was the the mountain itself, was it created in the middle of the one on the left, the big crater?
This one
Yeah.
was, in my view, it was likely created when this thing hit. When something this big hits, and typical speeds are 30 to 70 thousand miles an hour. That's a
Jeez.
lot of kinetic energy.
Yep.
And when these two objects hit, basically the target and the thing that did the impact turn for a while into molten. They're liquid. And it splashes down and then it rebounds for a moment. And as it's just starting to rebound, it freezes. And that's where you get these central craters. And then later this one hit, and then this one hit.
So that's
And you
not
can
a
see other
volcano.
hits too that are later than when this was formed.
Now, if that weren't centered in the I don't know how to say that,
Albategnius.
if that were not centered in that crater, would that indicate maybe volcanic?
No, I don't think so.
Okay.
And it can look non-centered here because you're looking around a curved moon.
Okay.
Yeah, it's foreshortened a bit.
Well, also you're tricked by the fact that there's another crater there to the lower left
Yeah.
Yeah.
that obliterates the edge of the big
I mean,
crater.
Yeah.
Here,
And
Yeah.
it's got its own central peak.
It does too. Yeah.
No, in the far left, Jerry, the far left image. The larger crater within the crater. There you go.
Yeah.
Right
oh,
there.
over there, yeah.
But I don't suppose modern day science has ever seen one of these actually happening.
Not a
filling
big
with-
one.
Not a big one. You'd see a big lit up spot on the moon, wouldn't you?
Yeah,
For
we
a
may
short
see
while.
that. We
A
may
lot of
see
amateurs.
I'm sorry.
What?
Go ahead,
Oh,
Jerry.
I was going to say a lot of amateurs take videos of the moon.
There
so
there
to
was
get
a
us-
call among the occultation people to video the moon during
Yeah.
the total eclipse to see if anybody could spot any impacts because there was a minor shower going on. But also, oh, I lost it. Never mind.
Well, we're going to go inside the moon later, but if we had something this size as the one on the left happen, would it still be filled with lava? Would it have magma from inside the moon?
No.
No, this magma was from
Long time
most
ago.
likely from the impact. It's not from inside the moon.
Oh, I see. The
Now
meteor.
the seas could be from the surface crust breaking through to a magma layer.
Oh, what I was going to say was that asteroid 2024 YR4 that was in the news until we decided it wasn't going to hit us still has a 1% chance of hitting the moon, and that'll
Right.
be pretty spectacular.
And it's gonna pass by here closer to the moon than to us.
And would it result in something the size of that one on the left?
Probably not.
Yeah.
Not that big, huh? Well, most of the craters on the moon have a mountain or something in the middle. It's something physics about hitting water, and there's a follow-up.
That's exactly the effect.
You've seen these pictures of a drop of milk splashing in a dish of milk, and you get a surface, another rebound.
Wow.
Same
So
game
those are-
because this reflected when it happened.
Yeah, and those are probably good stop action pictures of what would happen here. What started as solid objects would actually interact as if they were liquids.
What I did, I like your comment earlier, Jerry, that when it hit, it liquefied the surface, and then as that central peak rebounded, it froze. That was interesting.
Yeah.
But does it throw
Well,
up?
you have
Does
to
it-
look at the state diagram of all the rocks. There isn't a single temperature where it solidifies. It goes from a liquid to a mush to a solid.
And then it scatters the dust around that our astronauts were plodding around on Apollo.
Well, it scatters dust elsewhere, and lots of micrometeorites make
Right.
the dust.
The surface is pulverized from a lot of small ones.
Well, I guess it goes without saying that there are telescopes constantly always on the moon, so we're not going to miss anything, right?
No, I wouldn't say that.
No.
Really? We might miss a big collision? You'd think they'd have something always focused on our moon. Well, it's going around us. That's
Should
the
be on the
problem,
backside.
right?
Now, there was a nice little video demonstration I found on the web, and I've captured a number of still frames from it where they're explaining the structure of the moon, the interior structure of it.
Ooh,
And this is looking at the thickness of the crust. This is the near side, which is thin, and this is the far side, which is thicker. So this side is 70 kilometers, and this side is 150 kilometers. This is the near side with the seas on it.
really?
And
The side
What's the
facing us.
composition of the white area that's underneath the surface?
this is inside the surface.
I know.
This is the mantle.
Is that solid or semi-solid?
No, this is all solid.
Okay.
The mantle is in here, excuse me, and that's what's illuminated here. You see there's 1, 2, and 3 layers here. This is an imaginary probe because the video says if you're drilling a hole through the moon, this is what you'd find. So this is the last 10% of the mantle, this one down here, and that is liquid.
10%.
And then inside that, this is the mantle, there is a liquid iron shell here that is 90 kilometers thick. And that shell has a dynamo effect, and it produces a very tiny magnetic field. And that's represented here as these continuous field lines of a dipole. And remember, these dipoles, it's not one big thing. It's usually a series of eddies that add up to these things. So this is the vector sum of any magnetic activity in here, any generator of magnetic field.
Do you suppose a compass would work on the moon?
You'd have to be pretty sensitive.
Oh,
Because here you take the word a very tiny magnetic field, and here a weaker than the one on Earth. So this is 1 Gauss on the Earth, and this is probably 100th of a Gauss, very weak.
I thought our magnetic field was about half a Gauss.
Yeah,
4.5.
roughly, yeah. I won't quibble over a half a Gauss. Order of magnitude. Early on, when I started as an amateur astronomer, it was in the 50s, and you'd read textbooks and stuff, and they were estimating things. And they said for astronomy, getting distances to plus or minus 100% of the estimated distance was a pretty good job, because it's really difficult to do. And so there's a lot of order of magnitude. In physics, we call it OOO, order of magnitude. And it jumps, between, do you mean one Gauss, 10 Gauss, 100 Gauss, 1,000? Those are jumps of an order of magnitude. So I've learned that when you talk about astronomy, you just talk about the order of magnitude. So in my way of thinking from the old days, there's no difference between a half and one. But of course there is. Now we have instruments that are very good.
but that small magnetic field we're looking at on the moon would not give the moon its own auroras, would it?
No.
Or
Well, it has
very,
no
very
atmosphere.
Also, the
It
moon,
has
I
no
think,
atmosphere, so even if it's hit by charged particles, there's nothing
oh,
to.
you need the atmosphere. I forgot.
Right.
well, contrary to popular belief, the moon does have an atmosphere. It's
Right.
made almost entirely of rocket exhaust.
We're getting there. Polluting both bodies. Wow.
Yeah.
Okay. So there's magma in the moon. That's the bottom line. There's liquid, or there isn't.
There is.
There is, and it's not far down,
It's pretty far down.
but it's not in the middle.
Yeah.
Oh, it goes all the way to the center.
Well, the very center is solid.
That's what I meant.
Is this washed out, or can you see it okay?
A little bit.
A little bit, but
bit.
it's good enough.
Okay.
Yeah, good enough. Good enough, Jerry.
So this is the crust of the moon, the mantle here, the soft mantle, the liquid core where the magnetic field comes from. And then there is a solid core, a solid iron core in the very middle of the moon, but it's very small. Basically, the moon is made out of crust and mantle of the Earth and of Theia from that collision.
And
I thought
green
it was
cheese.
cheese.
Green cheese on the outside. Yeah,
Yeah,
right.
green cheese. There you go. It's St. Patrick's Day.
Interesting. So is liquid always called magma no matter what body, or is that just an earthly version?
No, inside that's anything contained inside a volcano is magma
That's all magma,
till
which
it
is
comes out of the surface and then it's lava. But on
lava.
Io, it might be sulfur stuff.
Oh, and on
So the composition is not specified. And there
on
are ice volcanoes on some places too.
Europa, for example,
Yeah,
right?
Pluto.
Yeah.
Well, that's a liquid nitrogen or a nitrogen ice.
Now, this is a chart, a Chuck chart.
Yeah.
This
Yeah,
is showing the constellation of Leo, and we have Epsilon Leo and Lambda Leo up here. This is north heading toward Polaris. And this is where Amphitrite, the path of
I think it's
16
Amphitrite.
Amphitrite. And here we are right
Greek.
there. And so I sat down and worked out where these stars are and plotted it on a readable chart. So this is Epsilon, and this is Lambda up here. And this is where that March 17
Froze on us.
for the comet is.
Boy, this new screen is so much better. This is really nice.
Well, good.
Yeah, thanks, Jerry. These are nice. I like it.
You said
That
comet.
previous one, was that previous one high enough magnification you couldn't really make it to see the question mark of Leo?
It was out of the picture.
Okay.
Yeah. Just these
And-
two stars of Leo were in that picture. There's they are, Epsilon and Lambda.
Oh.
No other big stars. There's no Regulus in here.
In other words, this is a pretty useless chart.
Well, no, it allowed me to locate a useful chart where it is.
Okay. Well, that's
But
my
I put it
opinion
up there so it'll wake Chuck up and stuff.
A lot of these star charts, the artists have gotten a hold of them, and even though that they're something that you know what to look for, you can't see it for all the other clutter they put in there.
Yeah.
Are we talking about an asteroid in this?
Yeah.
Yes.
Well, you said comet a second
Oh,
ago.
sorry. I do this for comets too.
Oh, okay.
I'm an equal opportunity employer here.
And it's called Amphitrite?
Amphitrite.
Amphitrite, yeah.
Amphitrite. It's like Aphrodite.
Yeah.
This asteroid is at magnitude 9.5, and it was the 29th asteroid in order that was discovered.
Wow. Is it round like a planet?
No.
Oh, I'm glad you asked.
Because you're going to get a picture of it. There it is.
Now this is
Like a marshmallow.
there's
Wow.
a system, I forget the name of it, that figures out from its light, as it rotates from its light changes, magnitude changes, that figures out what the shape roughly is likely to be. But of course, it doesn't show anything down to the scale of big craters or anything. It's likely got big craters and structure, but it's roughly this shape. So it's not a sphere. And it in most of those charts, it would not be a planet.
Okay. It's
Because
not
it's
really
not
egg
round.
shaped. Sort of egg shaped. Different views here, different angles of it, I guess.
Yeah.
It's part of a family of asteroids. I don't remember which one, Hilda's or something. So it's if you put all those back together, you would have had a bigger asteroid in the past.
Yeah.
But is it in the belt?
Yes.
Yeah. Yes.
It is in the belt. Okay. Interesting. Well, it's not a danger to us if it stays
is.
in the belt.
This is the largest S-type asteroid. It's 120 miles in diameter, and
Wow.
probably the fifth largest after Eunomia, Juno, Iris, and Herculina.
Yeah, fifth largest in that family.
That's right. Yes.
Yeah.
It was discovered in 1854 by Albert Marth at the South Via Observatory in Regent's Park, London.
So something that's only 120 miles across, you guys can see out in the asteroid belt with your scopes?
You can't resolve it, but you can see the spot of light. It's bright enough.
Okay,
Yeah,
got
this
it.
one would just be on the threshold of binocular vision. Binoculars.
Yeah.
Wow.
How fast is it rotating? Would you be able to see that in your scope at all?
No. I mean, if you had a sensitive detector, that's how they get this.
Oh, okay.
But visually in a scope, you wouldn't notice it.
What is that word that means how bright an object is due to the color of it?
Albedo?
Albedo. What is it? A dark colored asteroid, or is it as light as it seems to be here?
This is an S class, which means silicates, I think. So it would be dark, but not as dark as carbonaceous.
Okay. And
Yeah,
it's
the
not
moon
going
is about 16% reflective.
to occult anybody soon.
I don't know. None that
What's
are
it?
passing over Santa Barbara anyway, or I'd know about it.
It's not an NEO.
Yeah.
Near Earth object, yeah. We got enough of those.
So anyway, as someone pointed out earlier, the vernal equinox is this Thursday at 2:01 a.m. Pacific Daylight Time. And that rings in the start of astronomical spring in the Northern Hemisphere.
Sun's right over the equator.
Yes, the sun passes from south to north of the celestial equator, getting ready for summer.
Ooh.
People that live in the tropics around the equator and the jungles down there, there's really no seasons unless you count hot and hotter,
Or rainy and not rainy.
rainy and not rainy. Our rainy season is delayed this year. I thought we started getting monsoons in December and January, but it's still March and coming down outside.
Well, I spent a lot of time in Hawaii on the island of Kauai because we have a big underwater tracking range out there. And it rained every day.
Is
You
that
know, if you
right?
don't like the weather, wait 5 minutes.
There are rainforests in the tropics and there are rainforests up in British Columbia that are totally
Yep, they're
different.
different kinds of rainforest.
Isn't that funny? Yeah.
Yeah.
Wow. Okay. Here is a map.
And if you look at the sky and where the sun is, this is the constellations that the sun, that the daylight part of the sky is in now, are all associated with water, because in ancient Sumeria, when they were making up the constellations, when the sun was in this part of the sky, they had their rainy season.
Huh.
Okay.
As long as we keep our lake filled, I'm
How did
happy.
they know that that was a teapot?
Yeah.
So this is Antares here. This is a very easy to find globular cluster right next to Antares. M4, which happens to be written on the moon here by an accident of timing. And this is the moon here heading toward last quarter. So the moon on this time at our equinox at 5 a.m. local time on March 20. So this is where the moon is near Antares. And Antares is a very interesting star. It's a magnitude 1.1. And this is about 5 o'clock in the morning.
Oh.
So, this is on the 20th. Yeah, that's the equinox thing, 20th. And so, very interestingly, Antares is a giant star, giant red star. If you put it in the
Where the sun is.
yeah, it would the surface would be out between Mars and Jupiter in the asteroid belt.
Whoa.
It is 550 light years away, and they have been able to image the disk using radio astronomy, the VLA. There's the very large array, and there's the ALMA in Chile. And they can see these layers to the resolve these layers in Antares.
Would that be, where would Mu Cephei, Herschel's Garnet Star?
That
Would that be about the same?
that would be bigger as far as the brighter parts of this. The brighter parts would go out farther, more out toward between Saturn and Uranus, where you see that outermost edge on this one.
Oh, okay.
So here it shows with placed Antares where the sun is. You can see Earth and Mars, and then here is the lower chromosphere and the
Upper photosphere.
The photosphere is in here. So this is, and then, so this is what Alma can see. And this is another layer out there, the top of the chromosphere. Oh, this is the bottom of the upper chromosphere. And this is the upper chromosphere. And this is a wind acceleration zone, which they see that goes out to between Saturn and Venus. But the actual, what we see, the lower chromosphere, this is what we see as the sun for us. We see this, which is now here between Mars and Jupiter. So this would look like the surface.
This is a good, this is a nice chart.
When you look at it, yeah, when you look at a chart, I mean, when you look at a photograph of a solar eclipse, you can see the chromosphere sticking out with all of its flowers and stuff, prominences. And that's what you'd see around the moon if it were an eclipse that just exactly compensated for the photosphere. And then there's another layer up above it, the upper chromosphere, and then other layers going out here. But the star itself is this object in here.
Ah, do such super humongous monsters have exoplanets out there around them, you think?
They could.
They would be a superstellar system, wouldn't they? The planets couldn't be much larger than Jupiter, or they'd fire up, wouldn't they, and become a binary.
I don't know how that works. Usually the star takes up most of the debris that's around to make the stuff, so there might not be anything left over for large planets. But then again, maybe it just, there's so much stuff out there that large stars form large planets.
And this is the end phase in life of a star, Ron, that used to be much, much smaller. So if there were planets there, they've probably been gobbled up.
Yeah.
Well, they found 5,000 planets. So how many of them from the Webb are orbiting Betelgeuses and Antareses? Just
None,
curious.
I think, so far. None on supergiants.
None.
Yeah.
Okay.
So if this were the Earth at a red giant stage, it would have swallowed Earth and Mars.
That's
So
probably what happens.
yeah.
They swallow
But this
all
is a
their
bigger
planets.
star than our sun. It is going to explode. It's not going to just form a planetary nebula.
And there's even bigger than this, I understand.
Yeah.
Oh yeah, a lot bigger.
Yeah, that's Tim was talking about, Mu Cephei.
Yeah.
Is that the biggest?
No, but it's one of the bigger ones.
They keep posting pictures and comparisons of the even bigger ones they discover all the time.
Yeah.
Wow. Where are we now?
We're about to take a break while I try and get a video up.
That's an orbit.
This is a little pygmy galaxy.
Yeah. Believe it or not, there's a whole galaxy in there.
Huh.
Yeah.
But we'll be back to that.
Okay. You're not going to tell us what the circle was?
That was
that's
the
just
galaxy.
a highlight zone to
Oh.
look at.
An orbital path.
Yeah.
Got it.
No,
Well, it was the extent of the galaxy,
extent
not
of the
an orbital
galaxy.
path. Yeah.
Okay.
I love this stuff, man. Oh, man. Faith in Bagora.
How was the lunar eclipse at Camino Real?
It's
Tim
pretty
was
good. It's pretty nice, Bruce. A lot of people were cold. I wasn't. I got a nice little down jacket. I actually got hot.
I sat out on my deck and I wore ski clothes.
Yeah.
Were there enough people, shoppers, still left at that hour?
We got about 45. Well, what did we say? It was
47, I think.
47 people. It was surprisingly busy.
And we normally meet out there anyway every month on what, first Tuesday?
Yep.
Did we do that this month?
Yep.
So we met twice.
And somebody was passing along that information. People were asking about that. So they now know that it's been changed to what, the first Tuesday?
First Tuesday of the month.
Yeah. So yeah, it was pretty nice.
And you
Okay,
usually, okay, here we go.
this is look back time.
Ah,
Ooh,
This is a baby that starts 80 light years away. And so it takes 80 years for the light to reach us here on Earth. So there it is. There's when the light left the baby and it's coming toward us. And meantime, the baby is growing into an adult and then an old
Oh,
person.
yeah.
And this is the image that we would get finally when the person's 80 years old. We finally got the picture of it as a baby. So this applies to the edge of our universe where we see stars and galaxies that are at the edge of the universe. But there it takes 13.8 billion years for the light, the image of them to get here. Well, in that 13.8 billion years, as the baby is growing, this is the analog of that galaxy that we see moving away from us. So that it's now about 46 billion, 45 billion light years away. So this leads to some confusing nomenclature. But this is a very clear diagram of what's going on in that, analogous to the universe.
yeah. To be more accurate, it would also show that person moving away, but close enough.
Yeah. They picked 80 because that's a reasonable age for a person to be.
Yeah.
But where was I going to go with that?
well, there are
yes. So an object that you look at something and you see a photograph from the James Webb and it shows a galaxy 13.8 billion years ago when the light left it, but that galaxy is now 45 billion light years away. You're looking at an object that is 45 billion light years away, but you can't see it at 45 billion light years because it's another 30 billion or so till the light gets to us from where it is now. But in physics, they call the observable universe is anything that you will eventually see. But there is an absolute limit to things that you will eventually never see. And that is because as it goes away, it speeds up. And as it speeds up, it redshifts. And eventually it will redshift down so low that you can never see it. So that's the boundary between the observable universe. But if you talk about this colloquially, people will think you're talking about the observable universe, about what you can tilt your head up and see. And that's the colloquial meaning, but it's not the cosmology meaning. So are you confused yet?
Mm-hmm.
They should call it the eventually observable universe.
Well, I had an argument with AI and I asked AI, should I call this the observed universe? And AI said, yeah, that would be a good thing to use.
But when you say redshifts, it's going down or one direction on the electromagnetic spectrum,
Well,
doesn't it?
no, because the thing is very far away and the universe is speeding up, the rate at which something is receding from us is speeding up. And so it's redshifted because of its motion away from us. It's Doppler shifted away from us. And so as it goes away, it turns redder and redder and redder until finally it's down to where you can't see it anymore with our instruments or with our naked eye.
Wouldn't it
Does
go
it
into
ever
the
get to
radio?
a point where it's traveling faster than the speed of light away from us and you can't see it, period?
The object is moving faster than the speed of light away from us because the space it's in is moving faster than the speed of light away from us.
Right. So we
General
would never be
relativity
able to
says
see
that
it.
only for things in the universe are limited by the speed of light, but the universe itself can expand faster than the speed of light. So think of yourself as a kayaker, and you're trying to paddle upstream, but the water is going downstream way faster than you can paddle upstream. You'll never get out. You'll never get up the stream far enough.
Jerry, Alex Filipenko suggested that if you were looking at an image, like a live image as the universe is expanding, and you're approaching that area where it gets to the speed of light and then beyond,
Yeah.
that your image would slowly fade and then disappear.
Yes. And that's
But
why.
when you say red shift, you're talking about the color part of the spectrum. Doesn't it go below down into the radio waves?
It goes all the way down, it fades out.
And we don't pick them up from radio telescopes? Can't see an image, red
No,
or
no,
What you
what
see is the
you're
cosmic
forgetting the
microwave
part Tim
background.
just covered. That the speed of light, the light it emits is competing with the rate of expansion of the universe, and it can never get to us. It's like a kayak. You know, you're trying to paddle upstream, and you can only paddle at, say, 10 miles an hour, but the stream is going downstream at 20 miles an hour. You'll never get there. So once it emits light to you, say the paddling is light travels at 10 miles an hour, it'll never get to you.
and yet it doesn't slow down. It never goes below 186,000 miles a second.
That's right. The thing is traveling away from us at a parent speed higher than c, but it disappears. That makes it disappear.
The universe is expanding at a faster than c. The light isn't traveling faster.
No, the light is bound by c. The universe is not.
So have we reached the distance, the ultimate, the limit?
No,
We haven't
but we're
reached
still seeing things from 13.8 billion years ago.
through the web.
Through the cosmic microwave background.
I'm talking about the Webb telescope. Are all the telescopes looking as far as the Webb is? Those 5 or 6 new blobs at 13.8 billion. Wasn't that a Webb photograph?
Yeah, but the cosmic microwave background is the ultimate thing that you see.
Okay.
There, the light has been shifted way down into the microwaves.
Yes. Okay. We'll make that a topic to confuse ourselves with later. Okay, so this is a newly found galaxy that has almost no stars in it. It's named 3 Roman numeral X's and 1 5, so that's 35 in Roman numerals. That's the name of it, and it's in Andromeda. Let's see, where's the okay? Can you see this, or is it washed out?
No, we can see it.
Okay, so this is a map, a negative map. This is M33 down here. This is Andromeda, M31. And this is Andromeda XXXV, or 35. These are all the other dwarf galaxies that are orbiting around Andromeda. And they have their Roman numerals to identify them, and they are Andromeda satellites. So we have them around our galaxy too, the Magellanic Clouds, for example, and numerous very small things. But we're limited in our looks because of the disk of the Milky Way is in the way. So we get a very limited look. So they're studying what's going on around Andromeda with a series of charts and maps. And this one is the one they're focusing on, Andromeda XXXV.
Is Andromeda stuff considered part of the local group?
Yes.
So we're all in the local group. Okay.
So this is where this thing is located right here in a larger field of view. This is the photograph we saw a minute ago with the circle that identifies the galaxy. And that galaxy is located right here. It doesn't have the usual spiral structure you'd expect. But from proper motions of these stars, they have decided that this is a group that is a low dust companion of Andromeda.
If it were located inside Andromeda or inside our Milky Way, would it be considered a star cluster?
It could.
So it's about that size then.
Probably got more stars, but not a whole lot more.
But that's one of the theories about star clusters. They're little captured versions of what we're looking at here.
Globular clusters, yeah.
So it says not only is Andromeda 35 the dimmest and smallest known satellite galaxy of the Andromeda system, it's about 3 million light years away, making it very hard to spot in an amateur scope. The ellipse within the inset shows where this companion galaxy was discovered. And then it lists a citation. But This is
Oh, boy.
a timeline
Mhm.
for farthest galaxy away Hubble has seen with a redshift of 11. So this is the reionization era, and this is where modern galaxies form. But apparently there are things that are very early on that formed, and they think that this thing of Andromeda is one of those. So it gives us a look at very early galaxy formation. The population has, these satellites have very ancient star populations. They stopped forming stars about 10 billion years ago. And that's one of them, that's the satellite galaxy around Andromeda.
So where are we on this? On the left or the right? I can't tell.
This is the
Oh.
Hubble Space Telescope right there.
Oh, I see. Gotcha.
So this is zero. This is billions of years ago. This is zero. This is right now.
This is today.
Yeah, this is 13.8 billion years ago, where the Big Bang, and this is the cosmic microwave background that we see in microwaves.
Right.
And then there's a dark era when they are not emitting light because no atoms have formed. And then the atoms form, and then they make the first stars, and these dim red spots represent our uncertainty in that.
Hmm.
So
Yeah, Ron, the first stars are about 300 million years after the Big Bang, just roughly.
First stars or first galaxies?
First stars.
Stars. And there may be primordial black holes out there too, just ahead.
Oh,
But what
That'd be a
webs?
wonderful topic, Jerry, to talk about.
yeah,
It's really in a lot of recent magazines, Sky and Telescope, Science News, Scientific American, a lot of neat articles on primordial black holes before
Yes.
stars were ever born. Okay.
Because everything was closer together.
Yeah.
Well, my apologies, gentlemen, for not totally understanding the cosmic background that Chuck was talking about. Where would that be if it
By the
would
way,
be-
Ron, you're not alone.
is
Yeah.
it-
yeah, yeah.
It's everywhere, Ron.
Yeah,
It's
everywhere.
everywhere. It's not on the right. Right over there
Well,
at the
in this
beginning.
timeline, in a timeline, it's to the right.
Yeah.
But in
So
3D
Ron,
space, it's in all directions.
right. And Ron, these primordial black holes were posited in the 60s, and Hawking was one of the big guys to promote these things. And we may be able to see some of them now, or at least what they do, not really see them. So it's an interesting time to live, huh?
yes.
Yeah, and old man Hawking says they evaporate too.
Yes.
They're small.
Yeah,
Right,
if
but
they're
they-
small, and they would be evaporating right about now, the ones that would have some impact right about now. There's a formula that's in my Astro book I used to teach that gives the time base for this kind of stuff to happen, and we should be looking for them now, and folks are. They're really looking.
Do you guys have a black screen in the middle of the picture?
Yeah.
Yeah, that's a black hole, Tim.
Okay. Primordial black hole. All right.
Somehow
There
I've
you go, Tom.
I've got things
Yeah.
stacked here so that I can't.
It's up to Daisium.
It's,
Say, hey,
it's got a
Tim.
rectangular event horizon.
Yeah,
It's
Tim,
a
before we
great
sign
screen,
off,
though.
I will show up at the observatory.
Oh,
It looks pretty terrible, but if you'd love to keep me company inside a closed dome, I'd love it.
I might do that. I might do
Okay.
that. Okay,
And we'll
Tom,
get a
thanks for letting
count,
me know.
Chuck. We'll get a count, but I don't think it's going to be very hot.
Okay.
One.
Okay,
No,
well,
I've got to have
goodbye,
somebody
everybody.
open up the observatory
Bye.
because Isla won't be there today after all that work she put in yesterday. So,
Okay, thanks, everybody.
Are we
Okay,
done? Are we out of here?
yep,
I
yep.
thought
Yeah,
that
look
Lock
like-
my machine up.
okay.
Well, we'll see you next week, I guess, for number 212. Thank you,
Right.
folks.
Yeah,
Okay.
thank you,
Guys.
Jerry.
See
Thanks,
you
Jerry.
next week.
Appreciate it.
Bye now.
I got to figure out how to get out of this.
Yell Geronimo and we'll jump.
Pretty good, Tim.
I thought that was my
Okay.
protection. My
Okay, Tim, hope to see you.
All right, Tommy.
Okay.
I've been trying to take that box off of my screen and it won't go away because it's not me. It's not my protection service. I have a vast.
I can't get rid of it either.
Yeah.
Well, we've got the little X in the red box in the upper right. Let's try that.
It's live. That didn't help, did it? I guess not. Oh, that's just me. Very good. Um, bastard.